Okay, Assalamualaikum and good morning to Tuan Muhammad Rashid bin Zakaria. Today I'm gonna present the title of the Slump test. The code and subject is DCC 10022 Brickworks and Concrete Laboratory. My lecture name is like I said at the first, Tuan Muhammad Rashid bin Zakaria. I'm from class DKA 1B. Okay, let me start for the introduction. Concrete is one of the major construction material worldwide. The slump test is very simple and easy to handle it. It is also demands comparatively less equipment and can be done in short period of time. This advantage of slump tests have made it very popular all over the world. Concrete slump test is carried out from batch to batch to create the uniform quality of concrete during construction. Okay, next is objective. The slump test is performed to determine or measure the pressure and workability of concrete works. The main goal of concrete slump test is to get the best concrete for any construction works. Excuse me. This is the basic test of concrete strength to make sure that a consistent mixture of cement, rocks, sand, and water are being used during the process of construction to create a strong fresh concrete. Engineers often use the results of slump tests as the reference to adjust the cement water or adding plasticizers to increase the strength of the outcome concrete mix. Let's go to the theory. The theory is in construction and civil engineering. The concrete slump test is an uh, site test for a laboratory test used to measure how hard and consistent a given sample of concrete is before curing. The concrete slump test is in essence a method of quality control for a particular mix. The slump should be consistent. A change in slump height will demonstrate an undesired change in the ratio of the concrete ingredients. The proportions of the ingredients are then adjusted to keep a concrete batch consistent. The homogeneity improves the quality and structural integrity of the cured concrete. Slump is simply a term coined to describe how consistent a concrete sample is rather than using obscure descriptions such as wet and runny or runny. The height of the concrete mix after being placed in the slump cone differs from one sample to another. Samples with lower heights are generally used in construction, while samples with little slump are commonly used in construct roadways and pavements. The apparatus is one in this test we have using the seven apparatus. One is a slump cone, second is steel solid plate, third is steel tamping rod 16 millimeter diameter and 600 millimeter long. The fourth apparatus is steel ruler, 60 centimeter. The fifth apparatus is large pan. Next is trowel to mix with the ratio of 1 to 4, equal to 26 kilogram. That is the volume. The last but not least is the water cement ratio, equal to 0.5 to 0.65. The procedure is calculate the weight each ingredient based on the ratio provided concrete. The quantity of concrete produced based on a ratio 1 over 1, 1.5, 4, which means 1 pail for cement, 1/2 pail of fine aggregate, and 3 pail of coarse aggregate. Calculate the volume and measure of water with measuring cylinder under water cement ratio required. Place the iron pan on the floor and moisten it with some water. Make sure it is damp and no free water is left. Place the sand in the pan, add the cement and mix it with the sand. Add the coarse aggregate and mix thoroughly. Mix the water and dry cement ingredient thoroughly using trowel with 2 levels. Mix with the scope until well mixed. Then firmly hold the slump cone using the 2 foot holes on the steel base plate 2 times 2, uh, 50.8 centimeter times 50.8 centimeter. Uh, Sixth procedure is concrete is put into the mold of 4 layers, where each layer is compacted by 25 times with steel rod rounded at the end. Firstly, fill on the third 1/3 of the slump cone with the concrete mixture. Then lam the layer 25 times using the steel rod. Seventh procedure is add more concrete mixture to the 2/3 mark. Repeat tempting for 25 times. Then you fill up the whole cone up to the top. Then repeat tempting for 25 times. Next is remove excess concrete from the opening of the slump cone. Clean concrete fell on the seconds on the plate. Remove slowly the cone by lifting it vertically. Within over a period ranging from 5 seconds to 10 seconds, make sure the concrete sample does not move. Next, we wait for the concrete stabilize. Measure the slump height of or ruins of a concrete using a ruler. After the concrete stabilize, measure the slump height of the slump cone of concrete using a ruler. The reduction slump is measured to get difference height between the reference point and the highest point of the concrete to get the slump height. All debris must be measured and recorded if the sample undergoes shear or the ruin of collapsed rubble. Then this test must be repeated if it still shows the ruins, record the ruins and types. Okay, next I will showing you the types of concrete slump. The slump concrete takes various shapes, and according to the profile of slump concrete, the slump is termed as collapse slump, shear slump, and true slump. So there is 3 types of concrete slump. Okay, first thing, collapse slump. In a collapse slump, the concrete collapses completely. A collapse slump will generally mean that the mix is too wet, or that is a high workability mix for which slump test is not appropriate. Excuse me. It means the water cement ratio is too high, i.e., concrete mix is too wet, or it is a high workability mix for which a slump test is not appropriate. So next we will go to the shear slump. In a shear slump, the top portion of the concrete shear off and slip sideways, or if one half of the cone slide down an inclined plane, the slump is said to be a shear slump. The shear slump indicates that the result it is incomplete and concrete needs to be retested for valid result. If a shear if a shear or collapse slump is achieved, a fresh sample should be taken and the test is repeated. Second, if the shear slump persists, as may the case with harsh mixes, this is an indication of lack of cohesion of the mix. So the last one is the true slump. In a true slump, the concrete simply subsides, keeping more or less to shape. This is the one only slump which is used in various tests. Second, mixes of stiff consistent have a zero slump, so that in the rather dry range, no variation can be detected between mixes of different workability. However, in a lean mix with a tendency to harshness, a true slump can easily change to the shear slump types or even to collapse, and widely different values of slump can be obtained in different samples from the same mix. Thus, the slump test is unreliable for lean mixes. So we go to application of slump test. The slump test is used to ensure uniformity for different batches of similar concrete under field condition and to ascertain the effects of plasticize on their introduction. Second, this test is very useful on site as a check on the day-to-day or hour-to-hour variation in the materials being fed into the mixer. An increase in slump may mean, for instance, that the moisture content of aggregate as unexpectedly as unexpectedly increases. Other cause the third is other cause would be a change in the grading of the aggregate, such a deficiency of sand, too high or too low slump gives immediate warning and enable the mixer operator to remedy the situation. This application of slump test as well as its simplicity is responsible for its widespread use. So this is a degree of workability. So the ratio, when the ratio is very low, the slump millimeter is 0 to 25 and in is 0 to 1. Compacting factor is 0.78. Used for which concrete is suitable for the very low is very dry mixes used in road making, roads vibrated by power operated machines. For the low one, the slump millimeter is 25 to 50 millimeter. The slump in is 1 to 2. The compacting factor is 0.85. 0.85. Used for which concrete is suitable. For the low workability mix used for foundation with light reinforcement, roads vibrated by hand operated machine. For the medium, the slump millimeter is 50 to 100 millimeter. The slump in is 2 to 4. The compacting factor is 0.92. Medium workability mixes manually compacted flat slabs using crushed aggregates. Normal reinforced concrete manually compacted and heavily reinforced section with vibrations. So the last one is the height. Height is the slump is going to 100 to 175 millimeter, and the slump in is 4 to 7. The compacting factor is 0.95, 0.95. Height workability concrete for section with congested reinforcement, not normally suitable for vibration. So the table that I been talking before is workability, slump and compacting factor of concrete with 19 or 38 millimeter, 3 over 4 or 1.5 inch. Maximum size of aggregate. So this is the maximum size of aggregate and the application of slump test. So let me so the discussion. The slump of concrete take various shoppies, and according to the profile of slump concrete, the slump is termed as a true slump, shear slump or collapse slump. If a shear slump or collapse slump, if a shear or collapse slump is achieved, a fresh sample and should be taken and the test repeated. True slump is the only slump that can be measured in the test. So the true is only can be measured. Test measurement is taken between the top of the one has been removed. The shear slump indicates that the result is incomplete and concrete to be retested. Meanwhile, the collapse slump is in an indication that the water cement ratio is too high, concrete mix is too wet, or it is a high workability mix for which a slump test is not appropriate. So the discussion is almost the same like I've been talking before is the type of concrete slump, just almost the same. So let me end this with the conclusion. As a conclusion, slump test is to determine the relative water content of concrete depends on the loss in height of a sample obtained from a cone shaped mound. According to our result, we were done. Our slump is not too wet or too dry. It is such a perfect slump test. The look of freshly mixed concrete, how to use the concrete materials, and some safety tips when conducting the slump test in the lab. Okay, that's all from me, Muhammad Irfan bin Idris. So I hope this slide or this present can help you to doing this slump test easily and perfectly. Okay, that's all from me. Thank you. Bye bye. So okay, here we go again. So today I'm gonna be here to discuss or present my second experiment that is called the cube test. Okay. First of all, for the introduction, this test measures the initial compressive strength of concrete cubes, which are made, cured, and tested to very specific requirements. It does not measure or predict in any unique way the strength of the concrete in the structure. The test is simply a quality control test which measures the consistency of the concrete one in terms of one particular property, compressive strength, using an arbitrary test method. Testing the same concrete under different conditions, for example, specimen size, specimen shape, curing temperature, loading rate, will give different results. So we go to the objective. Here we get only two objectives. The first is a test conducted to determine the strength of concrete, and the second one is a compression strength test is carried out using cube test. The theory in this cube test is two types of tests are carried out to determine whether the concrete produced does follow the specifications given. They are compacting factor test, slump test, and VIP consistometer test, which are for wet concrete. As for hardened concrete, they are cube compression test and flexibility compression beam test. Hardened concrete test is usually carried out when the concrete is at age 3, 7, 12, 21, and 28. Concrete strength increase according to its age. So the last one, in general, concrete will have acquired 70% strength on the seventh day. So in here we have five apparatus. The first one is the concrete cube size 150 millimeter times by 150 millimeters. Sorry. The second one is compacting steel rod with size 25 millimeter times 25 millimeter. The third one is oil or grease. Fourth one, the compression test machine. The fifth one or the last one is the trowel. So we go to the procedure. For the first procedure is we have to prepare concrete with the design mix of 1 to 4 equal to weight 15.3 kilogram to make two concrete cubes and water ratio of 0.50 to 0.65. The second one, the concrete cube mold must be made from steel or cast iron with smooth inner surface. Every mold must have steel base plate to support and prevent leakage. The mold and base plate must be cleaned and applied with oil to prevent concrete from sticking to the sides of the cube. The base plate is attached to the mold by using bolts and nuts. So the fourth one, fill the cube. As you can see, the picture is for the number 3. So the fourth one is fill the cube with concrete in 3 layers. The fifth one, every layer must be compacted for 35 times. This process is carried out systematically and compaction is done uniformly to all surfaces of the concrete. So that is the picture for the number 5. So we'll go to number 6. After the top layer has been compacted, a thrower should be used to finish off the surface level with the top of the mold should be whipped clean. Immediately after making the cubes, they should be marked clearly. This can be done by writing the details of the cube in ink on a small piece of paper and placing it on the top of the concrete until it's demold. So it's like this only. It's like in this picture. So for the eighth one, concrete cubes are left to harden for 24 hours before the molds can be dismolded. So for number 9, after remolding, the concrete cubes are weighed before submerging it in water for curing. The weight of the cube is stated as 7.78 kilogram. Is also same like this picture, 7.78 kilogram. So the last one, the compression strength test must be carried out for concrete at age 7, 14, 21, and 28 days. So we have must end our discussion or my presentation. So the discussion, the inner surface of the mold shall be created with the grease oil because to prevent leakage during filling the concrete and to prevent the concrete from sticky to it. Otherwise, the hardening concrete tube won't realize from the mold. The ratio of amount of water to the amount of cement by weight is known as water-cement ratio. In a hardened concrete, strength is inversely proportional to the water or cement ratio. The quantity of water added to the cement while preparing concrete mixes has been known to exert tremendous influence on the quality of concrete. Water affect the durability and strength of concrete. The last one for the conclusion, and we will end my discussion. In the cube test is determine the compressive strength of hardening concrete. The apparatus of the cube molds, steel rod, hone float, compressive testing machines equal to CTM are used for doing the cube test. The ratio of cement, fine aggregate cost, aggregate and water 1/2 3 were used to prepare the concrete mixture after removing cube. The age of 3, 7, 14, 21, and 28 days in curing bed. The cube test can be done for the hardened concrete cube. According to our result, we were done our cube practical test in very successfully. But some of the factors, such as the first time we added water, we got dry mix, and after we add water, the concrete is too wet. The top surface was absorbed. Some water, some water from the concrete mix, the cement is spread through the air because of the wind. So that's the little problem for us to make this tube test successful. So that's all from me. Okay, thank you. Bye bye.